In this video, I want to look at subrings. Very informally, a subring is going to be a smaller ring inside of a larger ring, and we've already seen some examples of these. The integers is a ring inside of the larger ring of the rationals. And the rationals are a ring inside of the larger ring of the reals. So whenever we have a ring B that's part of a larger ring A, we call B the subring. This notion of subrings is the precise analog for rings of the notion of subgroups was for groups. So what exactly do we need to satisfy a subring? For a group, we know we needed a subgroup to be closed under inverses and the group operation, but what about for rings? Let's let A be a ring and B be a non-empty subset of this ring A. We want B to be closed with respect to addition, so adding two elements of B is still in my set B. We also need B to be closed with respect to negatives, so if I have an element in my set B, its negative also needs to be in the set B. And these are the two conditions I needed for an additive subgroup. So I do need it to be a subgroup of the additive group A. For rings, I also need B to be closed with respect to multiplication. So if I have two elements in B, their product is also in B. And if all of these things are satisfied, we say B is a subring of A. Let's look at some examples of this. One of the more basic examples, the rationals are a subring of the real numbers. Adding two rational numbers is still a rational number. Multiplying two rational numbers is still a rational number. And the negative of a rational number is still a rational number. So whenever we want to check if something's a subring, we need to check three things. Is it closed with respect to addition? Is it closed with respect to negatives? And is it closed with respect to multiplication? But there's also a more compact way of checking that a set B is a subring of A. We can say that B is a subring of A if and only if B is closed with respect to subtraction and multiplication. And this is because B is closed with respect to subtraction if and only if it's closed with respect to both addition and negatives, since subtracting is adding the negative. So let's see about using this in some examples. I want to show the subset of all matrices of the form 0, 0, 0x is a subring of the 2 by 2 matrices. In this case, there are two things I need to show. The first one, we start with two separate elements of this subset, so 0, 0, 0x and 0, 0, 0y, and we need to subtract them. 0 minus 0 is 0, and then the last entry is x minus y. And this is of the appropriate form. It has zeros in the first row and the first column, and the second row, second column entry is some number. The second thing we need to show, let's take these same two elements of this subset, 0, 0, 0x and 0, 0, 0y, and multiply them. We would have 0 plus 0 is 0. 0 times 0 is 0, and 0 times y is 0, so this is 0. 0 times 0 is 0, x times 0 is 0. So here 0 times 0 is 0, and then we have x times y, which is still of the appropriate form. So yes, this is a subring. Let's do one more. Let's show elements of the form x plus y square root of 2, where x and y are integers, is a subring of the reals. The first thing, we need to take two elements of this form. We'll say x plus y root 2 and a plus b root 2, and we need to subtract them. When I do this, I get x minus a plus y minus b root 2. Since x and a are both integers, we know that x minus a is an integer. And since y and b are both integers, we know that y minus b is an integer. So this is still of the appropriate form, an integer plus an integer root 2. The second thing is we need to take these same two elements and multiply them. To do this, we would FOIL. We would have xa plus xb root 2 plus ya root 2 plus yb times 2, since square root of 2 times square root of 2 is 2. Regrouping, we have xa plus 2yb plus xb plus ya, root 2 once I factor out the square root of 2. X and a are integers, so xa is an integer. Y and b are integers, so 2yb is an integer. And if I add two integers, I still have an integer. Similarly, we have that xb plus ya is an integer. So this is of the appropriate form, and this is a subring of the reals.